Okay, ladies and gentlemen, this next question, we're still on the Test 1 review for Math 1033. Question number 2, let me glance down at my paper. Question number 2 is a division problem that involves scientific notation. And what it asks you to do is to write the final answer to the problem in standard notation, which means not to leave the final answer in scientific notation, but to expand it back out like a normal number would be written. So let's go ahead, come on down with me to the paper, and we are going to look at the problem. Here we are. We have 4.2 times 10 to the 7th power divided by 2 times 10 to the negative second. This number is already in scientific notation, and this number is already in scientific notation, and we're asked to divide the two quantities. I think the easiest thing to do is to mentally break this up as two problems. We're going to look at that portion of the problem and this portion of the problem. This is sort of arithmetic, this is directly arithmetic, and this is really algebra. 4.2 divided by 2 pretty easily is 2.1. This is still a multiplication between these two quantities. And if you have a base to a power divided by a base to a power, one of the laws of exponents you can use is to leave the base alone, and you will subtract the powers. Division says take the top exponent minus the bottom. The top exponent is 7 minus the bottom exponent is negative 2. So this is where we are so far. We have 2.1 times 10 to some power. Now what we're going to do is we're going to do the arithmetic on that power. The opposite of a minus becomes a plus. 7 plus 2 is 9. Now, this answer, 2.1 times 10 to the 9th power, is a correct answer, but the directions on your problem said to write the answer in standard notation, which means that we need to expand it back out. Because this is a positive 9, we take this decimal and move it 9 places to the right. So we have a 2 that already was there, the 1, and then of course we're going to need to put in 8 zeros. 1, 2, 3, 4, 5, 6, 7, 8. So when I write this out, wow. I guess that number is so much out of most of our leagues that we definitely know it's not a bank account, but there you go, all right? One of the things that I try to teach students in Math 1033, when a number is extremely large, the power on the 10 is a positive number. In fact, a large one, the more zeros there are. When the power here is a negative, this is not a large number, this is actually a tiny and tinier decimal. Okay, so this is our final answer to this problem.